These are the notes for lesson 5.4, complex and imaginary numbers. If you recall from the previous section, we solved using square roots. Now we know that sometimes we can't take the square root if there's a negative underneath the radical. In this section we're going to talk about what we do with those numbers and how we can actually simplify them using what we call the letter I. So complex or imaginary numbers, we use I to represent the imaginary number, and that is the square root of -1. And we use this so that negative radicals can be used. So here we have I is equal to the square root of -1. So if we have I squared, that means that we're squaring the square root of -1. So I squared is actually -1. So if we do I cubed, we're going to do the same thing. I cubed is the same as the square root of -1 squared times the square root of -1. So we know that this first part here is -1. So this is -1 times I, which is -1I. So we can simplify multiples of I. So then I to the fourth is the same thing. So we have the square root of I squared and the square root of -1 squared as well. If we square those, they're each equal to -1. So -1 times -1 is 1. Now for example 1, we are simplifying radicals with i's or with negative square roots. So if you think back to your multiplication rule for square roots, or for roots, we can split this into the square root of -1 times the square root of 4, because we know that -1 times 4 is -4. We know that the square root of -1 is I, so we can just rewrite that as I. We know that the square root of 4 is 2, so this is I times 2, which we write as 2I. So the square root of -4 is 2I. Part B is -9. We can do the same thing, so write it as factors. So this is the square root of -1 times the square root of 9. We know that the square root of -1 is I. We know that the square root of 9 is 3, so this is 3I. And part C, square root of -28, so this is the square root of -1 times the square root of 28. Now 28 is where we need to look at our prime factorization. So I know I can divide 28 by 2, and that will give me 14. I can divide 14 by 2, and that will give me 7. 7 is divisible by 7, or 7 divided by 7 is our 1. Again, we want a 1 at the top, and then these are our prime factors. So notice we have a group of 2's, so we know that the square root of -1 is I. We're multiplying all these together, so we have a 2 on the outside, and then still underneath the square root we have a 7, because the 7 doesn't have a pair with it. And then we can just rewrite this as 2I times the square root of 7. So we always put our coefficient in front of our I, just like we would a variable, and then the square root comes after that. So complex numbers are written in the form A plus BI, where A is the real part of the number, or any real number, and BI is the imaginary part. And A and B are real numbers. So on the left-hand side, if B is equal to 0, we have no imaginary part. So these would be our real numbers, which we talked about in chapter 1. Real numbers we know can be broken down into rational numbers, which can be written as fractions and decimals, and irrational numbers which we know that cannot be written as fractions, and their decimals don't repeat and they don't end. So again, real numbers can be broken down into rational and irrational. In the same way, imaginary numbers can be broken down into imaginary numbers or pure imaginary numbers. And pure imaginary numbers are when A does not equal 0. So basically we're missing that real number part, and it's only an imaginary part. So we're going to look at how to categorize imaginary numbers in this next example. So example 2 says to categorize the numbers below. So part A, we have -4I. Now notice we don't have a real number in front of the imaginary part of that number. So that means that this is a pure imaginary number. So -4I goes in our pure imaginary numbers. Part B is 3/5. We know that this is a fraction. There's no I or no imaginary part to it, so we know that that's going to be a real number. Example C is 2 plus 4i. So we know that we have a real part, which is our 2. And we also have an imaginary part, 4i. So this one is going to be just an imaginary number. So this is 2 plus 4i goes underneath our imaginary numbers. And again, you see that that's in the form a plus bi, where 2 is your a and 4 is your b. Part D is just 45. Again, we don't have an imaginary part, so that's just going to be a real number. And lastly, part E, we have I. Again, there's no real part. There's no just number or constant by itself. So that is, again, a pure imaginary number. So again, imaginary numbers are always written in the form a plus bi. So the real part comes first, or the real number or constant comes first, and the imaginary part always comes second. Complex numbers have properties just like real numbers do. So we're going to look at some properties that we can use with complex numbers. When we are writing each expression in standard form, I want you to think of I just like we would a variable. So we treat it just like a variable, only we can simplify it with the properties that it has. So here we have 2 plus 3i plus 4 minus 5i. So just like we can with variables, we can combine like terms. So we have two constants, we have a 2 and a 4, so we know 2 plus 4 is 6. And then we have two imaginary numbers. You know, this is a negative 5i, because subtraction is the same as adding the opposite. So a 3i plus a negative 5i gives us a negative 2i. Again, we always write the real part first and the imaginary part second. You could write it as 6 plus a negative 2i, or we could write it as 6 minus 2i. Part B is the same, only remember, again, subtraction is the same as adding the opposite. So if there's subtraction between our parentheses, we have to distribute the negative. So we can change our subtraction sign to addition. The 4 becomes negative, and the subtraction inside the parentheses becomes addition. And again, we just combine like terms. So we have a 2 and a negative 4 are our constants, so that would be negative 2. We have 3i and a positive 5i, which gives us 8i. So again, the real part or the constant comes first, the imaginary part comes second. Part C, when we have two parentheses right next to each other, we know that that means multiplication. So we can use our extended distributive property, or in this case you may call it FOIL. So we're going to start with our first term times our first term, which is 2 times 4, which is 8. And we need to distribute 2 times negative 5i, which is a negative 10i. Then we can multiply 3i times 4, which is 12i. And 3i times negative 5i, which is negative 15i squared. So we have I times I, so we know that that is I squared. Now we can simplify, so we still have our 8. We have a negative 10i plus 12i, which is a plus 2i. We have minus 15, and we know that I squared, if you go back to the previous page, that's the square root of negative 1 times the square root of negative 1, which is just negative 1. So 15 times negative 1. So we notice here we have subtraction, which is the same as adding the opposite. So a negative 15 times a negative 1, which is actually a positive 15. So 8 plus 2i plus 15. We know that 8 plus 15 is 23. So our final answer is 23 plus 2i. So again, once we have distributed or multiplied out, make sure that you combine like terms. And if we have any power of I, we have to make sure that we simplify that as well. For part D, I want you to look at this for a second. We have 3 plus 2i quantity squared. Remember when we square something, so for instance, if we have x squared, it's the same as saying x times x. So we're multiplying the same thing twice. So this is the same as saying 3 plus 2i times 3 plus 2i. So then we're going to multiply just like we did for part C. So 3 times 3 is 9. 3 times 2i is 6i. 2i times 3 is again plus 6i. And last, 2 times 2 is 4. I times I is I squared, so 4I squared. And again, combine like terms to simplify. So 9 plus 6I and 6I is 12I. 4 times, we know that I squared is -1. So this is 9 plus a -4, which is 5 plus 12I. So we're going to final answer 5 plus 12I. Our last example 4, we're solving equations with imaginary numbers. So this is just like the previous section, only now if we have imaginary numbers, we have to simplify them. So you're going to end up with real and imaginary solutions for all of these. So for part A, we have x squared equals -1. So if you notice, we don't have an x term, so we can use the square root to solve. So if we take the square root of both sides, the square root of x squared is just x. This equals plus or minus. We know that the square root of -1 is I, so x is equal to plus or minus I. For part B, we have the same type of thing. We just have x squared by itself. Since we have no x term, we know we can take the square root of both sides. The square root of x squared is just x. The square root of -16. Remember your plus or minus, positive or negative. And this is plus or minus the square root of -1 times the square root of 16. We know that the square root of -1 is I, so x equals plus or minus I. And we know that the square root of 16 is 4. And again, we always write our coefficient first, so this is x equals plus or minus 4I. For part C, we have 3x squared minus 10 equals -34. Again, notice we don't have an x term, so we want to get the x squared all by itself, and then we can take our square root. So the first thing we want to move is the -10, so we want to add 10 to both sides. So we get 3x squared equals -24. We need to get just x squared, so we need to get rid of the 3. So we're going to divide 3. So x squared equals -8. Now to get just x, remember to undo a square, we take the square root, both sides. Now in this case, again, we're taking the square root of a negative number. So this is plus or minus the square root of -1 times the square root of 8. So again, we need to simplify the square root of 8. So I know that 8 is divisible by 2, so 8 divided by 2 is 4. 4 is divisible by 2 and we get 2. 2 is divisible by 2 and we get 1. So we have 2 times the square root of 2. So let's simplify this. So we still have plus or minus. We know that the square root of -1 is I. We have a 2 out front because we had that group of 2's. And then under the square root we still have a 2. Again, the number needs to go in front of the I. So our simplified answer is x equals plus or minus 2I times the square root of 2. And for part D, we have -6 times x plus 5 quantity squared equals 120. So first we want to get rid of everything on the outside of our variable. So we want to get rid of -6. It's multiplied by what's inside the parentheses, so to get rid of it we have to divide by -6. So I have x plus 5 quantity squared equals -20. Now again, to get rid of a square, we take the square root. Now you could multiply this out as x plus 5 times x plus 5, but as we saw before, it's much faster to just take the square root. So if we take the square root, that gets rid of the square, and we just have x plus 5 equals plus or minus. Again, the square root of -20 can be broken into the square root of -1 times the square root of 20. Now let's look at our factors of 20. We can divide by 2. That will get us 10. We can divide 10 by 2 to get 5. We can divide 5 by 5 to get our 1. So we have a group of 2, so we needed 2 outside of the square root, and then a 5 underneath the radical. So x plus 5 equals plus or minus, again the square root of -1 is just I, times 2 square roots of 5. So we have x plus 5 equals plus or minus 2I square roots of 5. Now the last thing we need to do to get just x by itself is to subtract 5 from both sides. So if we do that, we get x equals -5 plus or minus 2I square roots of 5. And again, the real number comes first, so that's why I wrote the -5 in front of our imaginary part, because we always write the real number first. So our final answer, -5 plus or minus 2I square roots of 5. So again, you're doing the same steps that you did in the previous section to solve with the square root, but now we can actually simplify the radicals or the imaginary numbers.